short exec. So actually, a short exec sequence relate three modules uh, uh, in an exact way. So I will show you that what is the meaning of exact way. So let M, N, and P be R modules. So M and P are R modules. So between these modules, so I can relate modules, and I can move from one module to another module with the help of module homomorphism. So let's say F is an R module homomorphism from N to M. G is an R module homomorphism from N to P. Okay, and also here on this side, I am assuming that this is a zero module. So this is a zero module homomorphism from the zero module to M. And also on the right hand side, I am assuming that this is a zero. This is a zero module, and this is a zero module. This is a zero module on the right hand side. Okay, and this is a zero module from P to this zero module. So I just wrote these three modules. In fact, I wrote 5 modules. Here the the module which is on the most left hand side is called is a zero module, and the module which is on the most right hand side, it is also a zero module. So so in this way, I am relating these modules. Now this relation or this sequence is called a short exec sequence, because now this is a sequence of modules. So in general, when modules are written in this way, such that or you can say in a line, such that between between one module to another module, there is a R module homomorphism, or one module to connect it to another module through an R module homomorphism. So in general, you can say that this is a sequence, just a sequence. Now this sequence is called a short exec sequence. If it is exact at each stage. और अब एग्जैक्ट ईच स्टेज होने का मतलब क्या है? दैट इट इज एग्जैक्ट एट ईच स्टेज. ये शायद कुछ लोगों ने आपने जब पॉलीलॉग का कोर्स पढ़ा तो उसमें कॉम्प्लेक्सेस वगैरह पढ़े हों. तो एग्जैक्ट ईच स्टेज का मतलब ये होता है दैट कि whenever so स्टेज का मतलब है कि मैं किसी मॉड्यूल पे हूँ, लेट्स से so at this stage kernel of the previous okay कि kernel of the homomorphism which is coming on n, that is you can say that the kernel of the coming homomorphism, it is equal okay image of the image in case का image जो है image of the coming homomorphism is equal to the kernel of the going homomorphism. So this is the so this is called a short exec sequence. In general, this is a condition for a sequence to be an exact sequence. कि कोई भी सीक्वेंस हो, जैसे ये मैं कहा था कि मॉड्यूल्स की सीक्वेंस का मतलब ये है that between two modules, that modules are written in a linear way, and such that from one module to another module, we have a R module homomorphism. But this sequence is called a short exact sequence if this condition holds that at any stage, for example, this is a stage, so kernel or image of this map should be equal to the kernel of this map. At this stage, image of this map is equal to the kernel of this map. And also at this stage, image of this map is equal to the kernel of this map. So it's mean that this condition should hold. So in general, this is a condition for a sequence to be an exact sequence. But if we that is, so इसको अगर मैं further elaborate करूं तो क्या होगा कि हर स्टेज पे exact होना चाहिए. So it should be exact at this stage, at this stage. तो अगर वो m के ऊपर exact होगी, so if it is exact at m, अच्छा क्लास 2 मिनट आप होल्ड करेगा. So it if exact at m, so इसका मतलब क्या है कि it should be exact at m. So exact if it is exact at m, then what is the meaning of this thing that image of this zero homomorphism, image of the zero homomorphism, it should be equal to the kernel of f. Now what is the image of the zero homomorphism? Because zero homomorphism को जो image होगा वो zero ही होगा. So it implies that kernel of f only contains the zero element, which implies that kernel of f, which implies that f is an injective map. F is an injective map. Also, if it is exact at n, what is the meaning of this thing that image of f, that is now image of the previous map at n, this is the previous map or this is the coming map, and this is the out map. Okay, and here image of f, but for n this is the coming map and this is the out map. So image of f is equal to the kernel of g. Now if it is exact at p, what is the meaning of this thing? Now p, for p, this is the incoming map and this is the outgoing map. So it means that image of g, it is equal to the kernel of the zero map. Now what is the kernel of the zero map? So actually it maps every element to the zero element. So it means that its kernel is the whole module p. Now from here we implies that g is a surjective map. So now we got the sufficient and we got a necessary and sufficient condition uh, for uh, for a sequence to be a short exact sequence. And what is the condition that if this exact is a short exact sequence, then this f should be an injective map. Then this f should be an injective map. We also have this condition and we also have this condition. So in short, what we can say, or you can say that this thing also has a theorem or maybe a result that uh, that this that 0 m n p is a short exact sequence if number one, that f is injective, because what we have seen that it is exact at n if and only if f is injective, because all conditions are if and only if conditions. Number two, that so this f should be an injective map. Number two condition, that this image of f, it is equal to kernel of G. And what is the condition number three? Under this condition, it would be exact at n, and it should be exact at also at b. So it is exact at b if and only if G is a surjective map. So this is the third condition, that G is surjective. So if these three, so if for this short sequence, if these three conditions hold, then we will say that the sequence is a short exact sequence. So you can also take this thing as a definition. कुछ जगह पे definition में सिर्फ ये लिखी है. Now we will see a few examples of a short exact sequences. Number one, let's say here we have 2Z and Z and Z2. So between 2 and Z, there is an inclusion map, which also in this one, because every element of 2Z is an element of Z. So between these two things, we have an inclusion map, and from Z to from Z to Z, we have a map which take every element to its modulo class 2. So what is the and this is a zero map, and this is also a zero map here. So f is defined in this way, that if input is n, then output is also equal to n, because this is an inclusion map. And G is defined in this way, that if input is x, then output is equal to the class of x in modulo, that is x modulo 2. Now we need to check that this sequence is a short exact sequence. So we just need to check these three conditions, that f is injective, image of f is equal to kernel of G, and G is surjective. Okay, so one can see that f is an inclusion map. So inclusion map injective ही होता है, is always. So f is an inclusion map, that is f is injective. So this is the first condition. Now for the second condition, what we need to check, that image of f should be equal to kernel of G. So image of f, it is equal to 2Z, because जो 2Z होगा वो पूरा का पूरा इसके अंदर मैप हो जाएगा in Z, and the kernel of G, it is also अब Z से लेकर 2Z में जितने सारे even numbers होंगे वो 0 पे मैप हो रहे हैं, Z2 पे. So that's why it is also equal to the kernel of G. Now one can see कि ये वाला जो मैप होता है, ये एलिमेंट्स को क्लासेस में लेके जा रहा होता है, कि पूरे इंटीजर्स को 0 बार या 1 बार में लेके जा रहा होता है. तो अगर इवन होता है तो उनको 0 बार में लेके जाता है, ऑड होता है तो उनको 1 बार में लेके जाता है. तो every element, there are only 2 elements in Z2, and every element 0 bar or 1 bar. so 0 bar has a pre-image. Actually, fact in the pre-image of 0 bar, all even numbers are included, and 1 bar also has a pre-image, and in fact, all odd numbers are included in the pre-image of 1 bar. So that's why uh, one can conclude that this G is a surjective noun. So this is an easy example to see that this sequence is a short exact sequence. In fact, we can generalize this example. That if we have NZ, Z and Zn, so we know that there is an inclusion map from NZ to Z. From Z to Zn, there exists a natural map which take elements to the modulo class view. And also we have zero map. This is a zero map and this is a zero map. इनफैक्ट बाद में मैं बल्कि अभी मैं इन जीरो मैप्स को लिखूंगा भी नहीं, क्योंकि आप खुद समझ जाया करेंगे अगर मॉड्यूल लेफ्ट साइड पे और राइट साइड पे अगर मॉड्यूल जीरो है तो ये दोनों मैप जीरो मैप है. So in this case again one can check that this f is this f from nz to z is an inclusion map. And G from Z to Zn is a natural map such that every x output is equal to x mod of n, और इसको आप x bar भी लिख सकते हैं. So class, any problem in the definition in this example? Am I audible?
Yes, sir. No problem.
जी सर समझ आ गया.
Okay. Now next example. Okay, so let M and N be R modules, and now define a sequence in this way that here we have M direct sum n, and here we have M and N. Now just try to recall that we know that now M direct sum n it is isomorphic to M cross N. So it means that every element of M direct sum n could be seen as an ordered pair. It could be seen as an ordered pair. पहले भी हम ordered pair के तौर पर ही देखते हैं direct sum को. But initially we defined the sum of some modules, and what we have seen that there is a condition that sum is called a direct sum if the intersection of the module M and N is a zero module. But what I'm trying to say that you can say now you can see elements of direct sum of M and N as an ordered pair. So that's why here M direct sum n contain elements in the form of x comma y, where x is an element of n and y is an element of n. Okay. Now M and N be R modules. So now we are defining a sequence in this way that so here a typical element. So f के साथ डिफाइन किया कि अगर यहाँ पे एक एलिमेंट होगा x m का तो f उसको किस पे मैप करेगा x, 0 में. So f is defined in this way that f of x it is equal to x, 0. And g is defined in this way that here if we have an element x comma y in n in m direction n, then this image it is just the projection on m. So output is y. So G is defined in this way that image of x, y, it is equal to just y. Now these are well-defined maps because again, if you take x an element of m, so we know that x comma y should be an element, x comma y should be an element in m direction n. In the same way, if x comma y is an m direction n, it means that x is an element of m and y is an element of n. So जैसे मैं इसकी projection लूंगा on the second coordinate, so I will get y. So we know that y is an element of n. So these two maps are well defined now. Now what is my claim now that this sequence, अच्छा यहाँ पे भी zero involve होगा. What is my claim that this sequence is an exact sequence? So again, for this purpose, I need to check three things. So first, try to see that F is an injective map. So this is a short exact sequence. So first, try to see that F is an injective homomorphism. Or so why F is injective homomorphism? Because you can also check that kernel of F contains only one element, because something if X in the kernel of F. So what is the meaning of this thing, that image of X should be equal to the zero of this thing? So which implies that, and what is the image of X? It is equal to X comma 0 should be equal to 0 comma 0. So which implies that X is equal to, which implies that X is equal to 0. So it's mean that kernel contains only, that is kernel of F, kernel contains only the 0 element. So it shows that F is an injective homomorphism. Now the second part, we need to check that image of F should be equal to kernel of G. So G is defined here. So G यहाँ पे लिखा है. G को मैं initially लिखना just करूँगा. Now in this case, again, if we take image of F, so ये इसमें इस टाइप के एलिमेंट्स होंगे जिनका सेकंड कोऑर्डिनेट क्या होगा, 0 होगा. So image of F contain all those elements which are in this form. Now try to compute the kernel of G. And now by definition, kernel of G contain so all those elements such that their image under G it is equal to the 0. यहाँ पे 0 के इक्वल आएगा. It's mean that that is, और G of x y का इमेज क्या होता है, y के बराबर होता है. That is y is equal to 0. It implies that kernel of G contains all those elements such that their y coordinate is equal to 0. So you can write kernel of G also in this form because there is no condition on x. So सारे y coordinates क्या हो जाएंगे, 0 के equal हो जाएंगे. So something is kernel of G if and only if its y coordinate is equal to 0. So that's why kernel of G also contain elements which are in the form of x comma 0. So this thing shows you that image of F it is equal to kernel of G. Now the third condition, that G is a surjective map. why G is a subjective map? Because now try to see G, what is G doing? एक एलिमेंट अगर x, y है तो इसको कहाँ पे मैप कर रहा है? Y में मैप कर रहा है. So whenever we have y here, so we can take any ordered pair such that second coordinate is y. So the image of this ordered pair would be equal to y. So we can see in this way that whenever whenever we have y is an element of n, so you can always construct an order pair. अब अगर आपको first element आप 0 भी put कर सकते हैं, so you can always construct an order pair in m direct sum n such that the image of this element 0, y is equal to y. So this shows that G is a surjective map. So overall, this sequence is a short exact sequence. Now one more example. Okay, so let R be a commutative ring with unity and I is an ideal of R. So let R be a commutative ring with unity and I is an ideal of R. Okay, so in this case, define a short exact sequence in this way, that 0, because I is an ideal of R, so you can consider I as an R module. So we know that this I is also an R module because it is an ideal of R, so it could be considered as a submodule of R. So that's why it is also itself an R module. This R is also an R module because every ring could be considered as a module over itself. And we have seen earlier that R over I could also, we can consider R over I also an R module. Now define a short exact sequence or a sequence in this way, and we will see that it is a short exact sequence. Now again, there is a natural map because I is an ideal of R, so that's why the subset of R. So there is a natural inclusion map from I to R, and again from G to R over I, there is a canonical map or a from R to R over I, which take elements to its class. So f is defined in this way that whenever f of a it is equal to a, and G is defined in this way that whenever input is an element of R, then output is equal to the quotient induced by R with respect to I. So again, this sequence is a short exact sequence. So just अब मैं डिटेल में नहीं लिखूँ, डायरेक्टली लिखूँगा. Since this is an inclusion map and this is a natural map from ring to its quotient ring. So we know that this map is surjective. And also we know that this inclusion map is injective. So you can directly argue here that this is an inclusion map, this is an injective map. This is a natural map from R to R over I, which is we know that this is a surjective map. And also we can see that image of f, it is equal to I, which is equal to the, and यहाँ पे जो जितने I के एलिमेंट्स होता है वो यहाँ के 0 + I में जा रहे होते हैं, तो दैट्स वाई इसका जो कर्नल होता है वो भी I के इक्वल होता है. So this condition, or so these three conditions implies that this is a short exact sequence. Now we are interested in a short exact sequence which are in this form, which are like the second example, in which the middle module could be written as a direct sum of the left module and the right module. So that's why we have a definition of a split short exact sequence. That a short exact sequence zero to m bar or 0 and m bar to m. Now we are assuming that this is a short exact sequence of R modules splits if there exists a R module, if there exists a R module homomorphism T from m dash to m such that G composition T is equal to the I of m double dash. So first we will try to understand this definition, that when a short exact sequence splits. So what they are saying that it splits if you can find a map. So we already know that G is a map from here to here. So this is a map G. So if we can compute a map T from m double dash, okay, in this here the definition is m double dash. So if we can compute a map T from m double dash to m such that this condition holds. So what is the meaning of this condition? That actually it shows that T is a one-sided inverse of G. That is, if we first go with if we first apply T and then we apply G, it should be equal to the identity of m double dash. So यहाँ पे एक inverse होने के लिए तो दोनों साइड से inverse होना चाहिए. That first apply G and then T should be the inverse, should be the identity map, and then apply T and G, it should be the identity map. तो यहाँ पे हमें पता है कि G surjective है, तो इसका शायद complete inverse compute ना कर सके because surjective bijective होने की guarantee नहीं है. But at least इसका one-sided inverse का sense बनता है. That maybe there exists a one-sided inverse of G. So in fact in fact you can say that this short exact sequence splits if there exists a one-sided inverse of G. कि अगर इसका one-sided inverse of G अगर exist करे तो ये short exact sequence क्या होगी, split करेगी. That is, if there exists an R module homomorphism from M double dash to M, such that G composition T, it is IM double dash. So again, this is a definition of a short exact sequence which splits. But still, we need to see that why we are interested in this kind of short exact sequences. So, the next proposition shows you that why the splitting condition is important, because we will see that if a short exact sequence splits, then the middle module is isomorphic to the direct sum of the right module and the left module. So वाली जैसे हमें पता चलता है कि जो मिडिल मॉड्यूल है वो राइट साइड का लेट्स से इस फॉर्म में नजर आ रहा है जो मिडिल मॉड्यूल है जो लेफ्ट मॉड्यूल और राइट मॉड्यूल का डायरेक्ट सम है. तो इन दिस वे इस शॉर्ट एक्सेक्ट सीक्वेंस को फिर स्टडी करना इजी हो जाता है. So that is our so that's को मैं लिख देता हूँ. The next theorem or proposition shows that a short exact sequence splits if and only if M could be written as a direct sum of M dash and M double dash up to the isomorphism. ये क्या up to the isomorphism exactly तो नहीं लिखा जा सकेगा, but to the isomorphism we can write to the isomorphism. M could be written as a direct sum of M dash and M double dash. So now I will write the proposition the formal way. That if this is a short exact sequence, is a if or you can say that a short exact sequence splits if and only if if and only if rather than the split short exact sequence है. वैसे if and only if के साथ ये condition है, but just मैं अभी ये one sided condition कर रहा हूँ. Splits then the middle module M it is isomorphic to the direct sum of the left module and the right module. So this is a this is a condition. So that's why splitting short exact sequence is important. So now what is the proof? So again, we need to show that if the splitting condition holds, that is, what is the splitting condition? That you can find a T from M to N dash such that the composition of such that G composition T it is equal to the identity. So and using this condition, we need to show that M is direct isomorphic to the direct sum of M dash and N double dash. Okay, so इसमें टास्क क्या होगा कि हम पहले कुछ मॉड्यूल्स कंस्ट्रक्ट करेंगे which are such that M या कुछ सब मॉड्यूल्स कंस्ट्रक्ट करेंगे such that M is direct sum of sub modules which we will construct, and then उन सब मॉड्यूल्स को मैं शो करेंगे उनमें से एक सब मॉड्यूल M dash का isomorphic है, दूसरा सब मॉड्यूल M dash and M double dash का isomorphic है. तो स्ट्रेटजी हमारी कुछ इस किस्म की होगी कि मैं पहले M को शो करूंगा that it is equal to the direct sum of two sub modules of M, और वो दोनों सब मॉड्यूल्स कंस्ट्रक्ट करूंगा, and then I will show you that one sub module is isomorphic to M dash and the another sub module it is isomorphic to M double dash. So in this way I will prove the thing. So what is our assumption? That this is an splitting sequence, so that's why there exists F from M double dash to M such that G composition T it is equal to the identity of M double dash. और identity को चलो ऐसे लिख देंगे I से इसको in fact ऐसे मेंशन कर देता हूं, it is equal to the identity. So what is the first task? जो हमारा first step होगा, that in the first step so we will decompose, or we will write, so we will decompose M as a direct sum of its submodules. Okay, now for this purpose, so what is my task for this purpose? That this T, so इस task को perform करने के लिए, that if we need to show that we can decompose M as a direct sum of fifth submodule, तो मेरा पहला task ये होगा that this T is an injective. So थोड़ी सी देर में पता चल जाएगा that by this condition is important, that this T which I defined here, which is defined here in the definition, it is an T is an injective node. So again, that is the kernel of T only contains the zero element. Okay, for this purpose, take Y is an element of M double dash, such that image of Y it is equal to 0. Okay. Then what I can do, I can apply G on both sides. So from here, apply G on both sides. So what I will get, G composition T of Y, it is equal to G of 0. So now we know that G composition T, it is the identity map. So that's why, so here in G of 0, it is equal to 0. So here dot Y is equal to 0. So we took an arbitrary element. In fact, we took an arbitrary element from the, अच्छा यहाँ पे kernel of T है. we took an arbitrary element from the kernel of T because we need to show that T is an injective map. So that's why arbitrary map from the kernel of T, and we prove that that element, it is a zero element. So this computation shows you that this T is an injective. So we need this condition later on to prove to prove a fact. Okay, now again back to the main task that we need to decompose M as a direct sum of its submodules. So just try to recall direct sum की definition क्या होती है? That अगर मैं M को मैं decompose करता हूँ उसके सब मॉड्यूल्स के अंदर, लेट्स से N और P में, तो इसका मतलब ये कि M का हर एक एलिमेंट N और P के सम में फॉर्म होना चाहिए. So ये रिकॉल करते हैं ये बात that every element of M, because ठीक है डायरेक्ट सब के लिए हमें ऑर्डर पेयर देखने की जरूरत है, बट वी कैन आल्सो अप्लाई द डेफिनेशन ऑफ द डायरेक्ट सम that n direct sum if M is equal to n direct sum P, then or we can say that if and only if X could be written as a sum of elements of N and P, and intersection of N and P it is equal to 0. So if this condition holds, then we can say that if these two conditions holds, then we can say that M is a direct sum of N and P. So again, just try to see. So what is my claim that M, जो मुझे ये चीज शो करना थी कि M को डिकम्पोज करना था, तो उसके लिए मेरा क्लेम ये है that M is a direct sum of image kernel of G, and or you can say that kernel of G and image of T, because from here you can see that kernel of G is also a subset, is also a submodule of M, and image of T is also a submodule of M. So both are submodules of M. So what is my claim that kernel of G, that M could be written as a direct sum of image of G and kernel of T. So here, so we know that that kernel of G and image of T are some modules of M. Okay. So for this purpose, first I will try to show this condition that every element of M could be written as a sum of an element of kernel of G and an element of image of T. And then I will show you that the intersection of these submodules is equal to 0. So if X is an element of M, then try to see that it could be written in this way. I am just adding TG minus TGX and subtracting or also adding TGX. So I am adding this TGX. Again, TGX is an element of M because in X, first I am applying G and then I am applying T. So it is also, so what is my, so X could be written in this way. So now what is my claim that this element that this is an element in the kernel of G, and this is an element in the image of T. So this fact is obvious, not very difficult to see that why it is in the image of T, because actually this element could be written in this form, that Tgx, it is written, it could be written in this form. So it shows that this element, the output is in the image of T. So this fact is not very difficult to see. Since so this implies this. Now, for this condition, we need to show that this element is sitting in the kernel of G. So just apply G on this element. So just apply G on this element. अच्छा, क्लास ये याद रखिएगा कि टी जी हमारे पास आइडेंटिटी के बराबर नहीं, क्योंकि अगर टी ही आइडेंटिटी के बराबर होता तो ये दोनों एक्स आ जाते तो हमें कोई चीज नहीं मिलती. जी टी आइडेंटिटी के बराबर है, बिकॉज मैं कहता हूँ वन साइडेड इनवर्स है, बट टी जी आइडेंटिटी के बराबर इन जनरल. So that's why we can write x comma m in this way. Now what I am claiming that this element x minus tgx is in the kernel of G. So for this purpose, I need to show that whenever I will apply G on this element, then the answer should be the identity. So it is equal to G of x minus G of tgx. Now using the associative property of functions, I can write this thing in this way. And now I know that this is the identity map. This is the identity of m double dash. So identity को gx के साथ operate करूँगा, so I will get gx. So gx minus gx, and it is equal to 0. So what we have seen that this thing is equal to 0, which implies that x minus tgx is x minus tgx is in the kernel of G. So class, now what we have seen that whenever we have x as an element of M, it could be written in the form of y plus c. हमने दो elements की form में लिख लिया, where y is in the kernel of G and c in the image of T. So actually we achieved this step. मैंने कहा था direct sum के लिए दो step होना जरूरी है कि first every element of M could be written as a sum of elements of modules which are involving in the direct sum, and then this is the next step that we need to show that there is some their intersection is equal to C. अच्छा, अब तक हमने कहीं पे इस कंडीशन को यूज नहीं किया जो मैंने शुरू में प्रूफ करी थी, that this T is an injective. ये जो T हमने प्रूफ किया ये इंजेक्टिव है, और इसको इतना प्रूफ इतना डिफिकल्ट नहीं था, but we will use this fact. So now so this thing implies that अब तक हमने सिर्फ M को ये लिखा है that M is just the sum of the kernel of G and the image of T. But now in order to show that this sum is a direct sum, we need to show that their image we need to show that their intersection is equal to 0. So let y is an element of kernel of G image of T. तो हमारा टास्क क्या होगा? हमारा टास्क ये होगा कि हम ये शो करने की कोशिश करेंगे कि इसका जो y है वो 0 एलिमेंट की इक्वल है. So if so, so why अगर कर्नल ऑफ जी में है एंड y किसमें इक्वल है इमेज ऑफ t इमेज ऑफ t का it's from this condition we can apply that y it is in the image of t, that is there exists an element z in m double dash such that image of z under t it is equal to y, because y it is in the image of t. And also from this condition we can apply that g of y it is equal to 0. So we have these two conditions. So using these two conditions we need to show that uh, uh, y it is equal to 0. Now if I apply g on both sides, so what will happen from this condition that or t on both sides? तो यहाँ से मुझे कोई चीज मिलेगी नहीं, because I don't know कि what is t of g. तो यहाँ से g of t के बारे में पता है, but we don't know about t of g. So that's why मैं यहाँ से लेके चलूँगा. So I will apply g here on both sides. So here I will get g of y and here I will get g of t of z. Okay, now from here we know that this thing is equal to 0, and what is g of t? It is equal to the identity of z. So this is equal to 0. So from here z it is equal to 0. So if z it is equal to 0 and which implies that y which is equal to t of z which is equal to t of 0 and it is also equal to 0. So which implies that y it is equal to 0. So class, what I did is that basically I have this condition that y it is equal to t of z. It is in the, because y it is in the image of t. So here if y, so it means that y for some element c in m double dash y it is equal to t of z. Now here applying g on both sides, I got this condition. Now we already know that this g of t it is equal to the identity, and from this condition we know that g of y it is equal to 0. It means that identity of z it is equal to 0, which implies that z it is equal to 0. So if z is equal to 0, so the image of z which is equal to y it is also equal to 0, because an R module homomorphism always map a 0 map into a 0 map. So from this condition, we can see that we took an element which is in the kernel and in the image, and that element y it is a 0 element. So this thing implies that image of image of t intersection kernel of g it is equal to 0. Now this thing implies that so what we prove that we prove two things. We prove that m could be written as a sum of image of t plus kernel of g, and also what we prove that image of t intersection kernel of g is 0. So which implies that actually this thing implies that M is a direct sum of kernel of G and image of T. बट स्टिल यहाँ से हमारा जो कंक्लूजन है ये थ्योरम का वो प्रूफ नहीं है, बिकॉज थ्योरम का जो कंक्लूजन है वो क्या कहता है दैट M is a direct sum of M dash isomorphic to the direct sum of M dash and N double dash. But here we just prove that M is a direct sum of kernel of G and image of T. Now जो हमारा नेक्स्ट टास्क होगा वो ये होगा कि मैं जस्ट इसको प्रूफ करने की कोशिश करूंगा that this kernel of G it is isomorphic to M dash and this image of T it is isomorphic to M double dash. तो ये मेरा नेक्स्ट टास्क होगा. तो जैसे ही मैं इन दो इसको M dash का isomorphic प्रूफ कर लूंगा, इसको M dash का isomorphic प्रूफ कर लूंगा, it will show that M is isomorphic to M dash and N double dash. So actually we are just using the splitting condition. So using the splitting condition, so first we prove that every element of M could be written as a sum of an element of kernel of G and an element of image of T. हमने prove that here we are using T. Then we prove that their intersection is equal to the identity. And now we need to prove that this kernel of G is isomorphic to M double dash. Now this G it is just a map from M to from M to M double dash. So using the F को मैं यूज करता हूँ. F को यूज करता हूँ. That if F, we know that F from M dash to M is an injective R module homomorphism. So using the first isomorphism theorem, what I can say that F dash, that M dash over kernel of F, it is isomorphic to image of F. So F तो इंजेक्टिव मैप है, तो कर्नल क्या हो जाएगा, किसके इक्वल हो जाएगा, 0 के इक्वल हो जाएगा. और शॉर्ट एग्जैक्ट सीक्वेंस की वजह से जो इमेज ऑफ F है वो किसके इक्वल होता है, कर्नल ऑफ G के इक्वल होता है. So this thing implies that M dash किसके आइसोमॉर्फिक हो जाएगा, कर्नल ऑफ G का आइसोमॉर्फिक हो जाएगा, बिकॉज पहले फर्स्ट आइसोमॉर्फिज्म अप्लाई किया, which implies that M dash over kernel of F it is isomorphic to image of F. Now we know that image of F is equal to kernel of T since the sequence is a short exact sequence and this kernel is equal to 0. इसका मतलब M dash किसके isomorphic आ जाएगा, kernel of G. Okay, now for the second task, just we know that T is a map from M double dash to M. Now again, using the first isomorphism, we also know that, so we proved earlier that T is an injective, जो हमने बिल्कुल शुरू में प्रूफ किया था, जो अब हमारे यहाँ पे काम आने वाला है, that T is an injective R module homomorphism. So again here M dash over kernel of T using the isomorphism theorem. किसके isomorphic है? Image of T के isomorphic है. और ये चीज किसके बराबर है? T इंजेक्टिव मैप है तो ये चीज किसके बराबर है? 0 के बराबर है, which again implies that M double dash is isomorphic to image of T. So ये चीज हमें प्रूफ करना थी that kernel of G it is isomorphic to M dash and image of T it is isomorphic to M double dash. So using this condition, so using this fact which we already proved, and this condition and this condition, we can say that M is a direct sum of M dash and M double dash. So let's say using 3, 1 and 2 इस तरह से कह दें. So from 1, 2 and 3 we can apply that M is isomorphic to M dash direct sum M double dash. Okay, so as I said that actually this condition is an if and only if condition to show that a sequence is an splitting sequence. तो कन्वर्स इसका प्रूफ करना कोई मुश्किल काम यानी कि नहीं है. So converse is also true because what I need to show that अगर जो sequence है that if a middle module could be written as a direct sum of the left module and the right module, that if the middle module is the direct sum of the left module and the right module, then we need to show that this sequence is an splitting sequence. So agar if this condition holds, then we know that what is the map here, that यहाँ पे एक्सेस में मैप हो रहा होता है, जैसे हम लोग को पता है x, 0 में मैप हो रहा होता है, एंड यहाँ पे x, y कहाँ पे मैप हो रहा होता है, y मैप हो रहा होता है. To show that so this is a map F and this is a map G. So to show that the sequence is a splitting sequence, you just need to construct T from here to here such that T composition G, G composition T is the identity. So now define T in this way that if you have an element Y in M double dash, so it will give you an element here 0, y. So T is defined in this way that T, y it is equal to 0, y. Now what we can say that using this T we can show that this sequence, because split की condition ये होती थी ना that there exists some map T from M double dash to the middle module such that the composition G composition T is the identity. So again, what is my claim that this T, which is from M double dash to M dash direct sum T defined in this way. So defined in this way. So this map actually is splitting the sequence. So if you take the composition of G, with T, so this is equal to so G composition T किसके equal है? so पहले t apply करेंगे so I will get 0 comma y and then जब जैसे इसमें g apply करेंगे so I will get y. So it is equal to the identity of y. So it implies that g combination d is the identity. So using this map, this map t from m double dash to the middle module is splitting the sequence. So that's why this shows that the middle module could be written as a direct sum of the left module and the right module. Then this sequence is always an splitting sequence. So actually, this thing implies that the given exact sequence is an splitting sequence. की क्लास तो यहाँ पे मैं लेक्चर खत्म करूँ तो शॉर्ट एग्जैक्ट सीक्वेंस की थोड़ी सी चीजें और हैं और फिर मैं कोशिश करूँगा कि नेक्स्ट क्लास में मैं इसको क्या कहते हैं प्रोजेक्टिव मॉड्यूल से कनेक्ट करने की कोशिश करूँगा. So thank you very much. Any problem in the lecture?
No, sir.
अच्छा मेरी वीडियो खुली हुई थी सारा टाइम पे.
जी सर.
वो बताई देते सही रहा. मैं बहुत ही रफ उसमें बैठा हुआ सही रहा. चले ये नजर है. चलो ठीक है सही. Okay. Thank you class.
Allah Hafiz, sir.